Sometimes, instead of you using the Pythagorean theorem, you could use these two shortcuts. These are shortcuts. They have specific names. The first name is called a 45, 45, 90-degree triangle. If you know a right triangle has a 45, a 45, and a 90-degree angle, then I can use this shortcut and apply it to any other triangle that's a 45, 45, 90-degree triangle. This pattern works. There is a secondary shortcut called a 30, 60, 90-degree triangle. And it has this relationship. Across from the 30 is the S side, across from the 90 is the 2S side, and across from the 60 is the S root 3 side. This is another shortcut you could use instead of the Pythagorean theorem. But you couldn't get to these two shortcuts without having the Pythagorean theorem. In the problems that you have, you cannot use the Pythagorean theorem to solve them, so you have to use these shortcuts in order to figure out what they are. When you look at number 7, you have an x, a y, and a 20. It is impossible to figure out what x is or what y is using Pythagorean theorem without figuring out what one of the variables are. The only way we can do it is using this shortcut as we do the problems. Now, the way the shortcuts work, they're very, very simple to use. If you know what each side is labeled, if you can figure out what S is, you just use S to figure out what the other sides are. For example, if I know that this side is, let's just say, whoa, that was weird. Let's just say that this side was 17. Then that would mean that since this side is 17 and that's S, then over here 2 times S would be 2 times 17, or this would be 34. And this other side, since the S is 17, it's S times root 3, it'd be 17 root 3. It's a shortcut. You just know, based off of this pattern, that a 30, 60, 90-degree triangle, it will always end up being following a pattern. Let's do another example. If I told you that this side was 18, and you know that this is 18 on the 2S side, then you should be able to figure out what S is. S would be 9. And this other side would be 9 root 3. That's how simple the shortcut is. You know the pattern, you put the pattern in, you use the pattern to find the missing pieces. It works also for a 45, 45, 90-degree triangle. Different pattern. S, S, S root 2. If I know that this side is 13, then the other side has to also be 13, and the hypotenuse would be 13 root 2. It's not a hard concept. You have to know the pattern. The pattern is going to be something I'm going to expect you to memorize. And so keep in mind, the way our textbook is and our problems are going to try to disguise, they might only give you one angle. 45, and then they'll give you a 90. And you have to figure out that the other angle is 45, and oh, it's a 45, 45, 90. Or they might only give you the 60 and the 90, and then you have to figure the other ones out. Or, because these two angles are the same, they might give you that these two sides are the same to make it a right isosceles triangle. And because it's isosceles, you need to know these two angles are the same, which makes it a 45, 45, 90-degree triangle. They will try to disguise them for you. But the patterns are still going to hold true. And if you want to know why these patterns or how this pattern was developed, it was developed off of the Pythagorean theorem. If you knew that you had a square for example, since I have squares here, and I have this perfect square that is 3 units long here and 3 units long there, and we're trying to figure out this distance from here to here, what you could do is you could use the Pythagorean theorem to figure that out. A squared plus b squared would equal c squared. 3 squared plus 3 squared is 18. And you square root 18. It breaks down into 3 root 2. Right? Now what if I did 5 and I did 5? It would be 5 root 2. If I did 7 and 7, it would be 7 root 2. It works like that all the time because eventually they say, you know what? Instead of plugging in numbers, let's plug in a variable. But what if it was x? It'd be x squared plus x squared equals this other side squared. 1x squared plus another x squared is 2x squared. Let's figure out what that side is. Let's square root it and square root it. And let me just do this little bit of math for you. Square root of 2x squared. Remember how we did this before? If there's a pair, one pops out. You get x root 2. Our pattern with our textbook is s root 2. You could do x root 2. The way I first learned it with a different textbook and a different textbook author, it was a root 2. But the reason why this textbook author went away from that is because they don't want you to get lost with the Pythagorean theorem and think, oh, this side's A and that side's B and that side's C, because we already use A for A squared and B squared and C squared. So they decided, hey, let's use S for a side squared. Okay, that's why they do it that way. S root 2. The 30, 60, 90 degree triangle, S across from the 30 is the smallest side. The largest side is double that, 2s. Across from the 60 is s root 3. The reason why this one works is based off of an equilateral triangle. If all the sides were the same, then all the angles are the same. 60, 60, 60. What if you cut that down with the perpendicular bisector? Then you'd have a 30, cut that in half, which would be 30 and 30. And if this side here is equilateral and all the sides are the same, then whatever this is, xw squared, and this is going to be that squared, and this is going to be, okay, I'm trying to remember how I'm getting confused there. The way I learned how, okay, well, xy, oh, this is, see, that's half the distance, this squared, and then that's, they're doing Pythagorean theorem on this side. S, 2s, 2s. Let's just kind of like explain it like this. If this side is 2s, and this side is 2s, and this side is 2s, and you do the perpendicular bisector, you cut that 60 degree angle in half, you get 30 on this side and 30 on this side. Half of 2s is an s on this side and an s on that side. And if you had an s and a 2s, and you were to do the Pythagorean theorem on this, you could find that third side, which will be s root 3. That's what they're doing here. S squared plus this thing squared equals that thing squared, which comes out to 4s squared. Take away the s squared is 3s squared. If you square root both sides, let me do that for you. There's the pair. Pops out, it's s root 3 every single time. That's the reason why it works. What I would recommend to you is that I do it in this order. Smallest is 30. S. Across from the 90 is the largest. I go across from the 90 is 2s. And in the middle, 60 degrees is in the middle, is s root 3. So that's what we're going to do. We're going to do problems that look like that. We're going to learn the pattern. And that's a level 1 way to do it. Now, I said level 1 because if I know this, I told you this was 5. You can plug that in, 5 root 3, and double it. It would be 10. the way they are going to mess with your brains is they're going to throw in something that gets really ugly if they throw in, let's say, that this side, let's say this side is equal, that's not what I wanted to do. Is equal to, let's say, 10. Sometimes what they're going to do is they're going to throw in a number that is on the root 3 side. And so if I throw in that this whole number is on the s root 3 side, then what you're going to have to do to figure out what s is you're going to have to set up a little equation to figure out what it is. You're going to set up something like s root 3 equals 10. And sometimes to get s by itself, sometimes you have to divide by a root 3. If that's what you have to do, this is the reason why you learned how to rationalize something back in unit 0.2. That way you can figure out that s is equal to 10 root 3 over 3. Some of these answers are going to look really, really ugly. Like when you have to figure out that this is 10 root 3 over 3, some of you will freak out or say, oh, that can't be the right answer. It is what the answer is. You're Honors Math 2 students, so don't freak out when you see ugly answers. A lot of times the answers get really funky, and then you have to double it. How do I double this? How do I take 2 times the 10 root 3 over 3? Well, it's 2 over 1, and it multiplies outside times outside. You would get 20 root 3 over 3. Some of your answers get really messy. Let's look at number 7. When you look at it, there is no way to do the Pythagorean theorem. Our answer is supposed to be in simplest radical form. The first thing I would do is I would write down 30, 60, 90. I would write out every angle in the problem so you know what's what. And then what I would do, just like these 3 directions say, label each side by the angle it's across from. What's across from the 30? S. What's across from the 90? 2s. What's across from the 60? S root 3. That's what I recommend that you do every single problem that's a 30, 60, 90. You are not given x, you are not given y, you were given the s root 3 side is the same thing as 20. I must circle that. That's how you figure out what s is. You have to make an equation based off of s root 3 is the same thing as 20. And this is where that ugly answer comes into play. Since s is multiplying root 3, you're going to divide by root 3. You may have to rationalize it. Simplest radical form, yes, you will have to rationalize it. Let's multiply by root 3 over 3. Let me show you my work up here. Makes the pair. Inside and outsides cannot mix. 3 does not go into 20. So my s side is 20 root 3 over 3. Since s is 20 root 3 over 3, I now know what the variable y is equal to. 20 root 3 over 3 is my y value. X is double that. How do you double this? You multiply it by 2. You multiply the numerator by 2. That means you multiply the number in front by 2. 2 times the 20, let's just show my work for this. 2 times 20 root 3 over 3 would be 40 root 3 over 3. This 2 does not multiply inside a radical. You can't do that. And it's over 1. And we just multiply one thing. That is x. Multiply left to right, by the way. There's no plus signs or minus signs. There's no distributive property. Any questions? I have 3 more examples. Number 13. A square has a diagonal length of 13 meters. What is the side length of the square to the nearest centimeter? Well, if the diagonal's length is 13 meters, and they're asking me to go to the nearest centimeter, I probably should know how many centimeters are in 13 meters. Let's use some science here. And some Math 1 or Advanced Math 8. There's something called a conversion factor you learned last year. A conversion factor is where you go, I know how many meters and centimeters. There is something that's the same in both. And I want to get rid of meters, and I want to be left with centimeters. So I need meters to be on bottom of my fraction, and I need centimeters to be on top of my fraction, because meters divided by meters goes into it one time, and they will cancel out. So all I really have to know is how many meters and how many centimeters are in each other. How many centimeters are in a meter? That's a conversion factor. That means this multiplied by this, meters divided by meters, will go away. Top times the top means that 13 meters is the same thing as 1,300 centimeters. That's the diagonal. Right? What's the side length of the square? It tells you a square. And it doesn't tell you this is a 45, 45, 90-degree triangle, but it is. Every square's diagonal is a 45, 45, 90-degree triangle. It really helps when you're laying a tile floor if you have square tiles. I did have to measure this at one point in time. I was installing a floor with my brother. My younger brother is like a carpenter type of person. And we were doing something in my parents' house. And he did not know a 45, 45, 90-degree triangle. And he's way more handy. He was the foreman, right? Because he knew construction, and I'm a math teacher. And he was like, well, we got to figure out what that. And I go, well, if you know this side, that side's going to be the same distance. It'll be a perfect 45-degree angle. If you just measure to there and measure the same distance, it'll be a perfect 45-degree angle. He didn't know that this side was going to be the same as this side. He didn't get through geometry, really. It's kind of sad, but yet he had more experience with the laying of the tile and the grout than I did. But I did know the math behind it, which was kind of neat to be able to teach him that. Anyhow, long story short, 45, 45, 90, S. Let me just kind of draw that out. S root 2. The 1300 is on the S root 2 side. 1300 is on the S root 2 side. If I want to know what S is, I have to divide by root 2. Now it says nearest centimeter, so I would not rationalize this. There's no reason to rationalize when it says nearest centimeter. You're going to need to use a calculator for a decimal approximation anyways. So I would just take this to my calculator, 1300 divided by the square root of 2. And when your calculator, hopefully, switch it to a decimal if you need to. Nearest centimeter, nearest whole number. I'm getting 919 on my calculator. You can feel free to double check me on that. Now, personally, if you're measuring something in meters, you're going to measure this in meters too. Why convert it? I don't see why they do that here. It wouldn't make sense to me. Number 20. Find the value of each variable. If your answer is not an integer, express it in simplest radical form. What you should be doing in a problem like number 20 is we should be using, we could probably draw something here that would help us. What if we drew a perpendicular, something that was exactly at a right angle, right about, let's say, there? That might help us in a lot of ways. How could that help us if this was if I constructed a perpendicular there? Then I would know that whatever this side is, since this is 90 and this is 90 and that's 90 and that's 90, I would have a rectangle, and then I would know that this distance from here to here that I just constructed would be the same thing as A. B is not the same thing as 30, because 30 is from here all the way to there. But I could figure out what this other little side is. And then what I could do is I could figure out that this distance B would be the same thing as 30 minus whatever that C distance is. So how would I do this? Now you just have the 30, 60, 90 degree triangle, and if you know the two sides, you can start answering your other questions. I would label it. First thing I do, across from the 30, I call this S. Across from the 90, I call this 2S. Across from the 60 is S root 3. They gave me that 10 root 3 is the same thing as the 2S. We have to figure out what S is. This is going to be one of those doesn't come out pretty answers. 10 root 3 is the same thing as 2S. Divide by 2. Outside and outside. S is 5 root 3. S is the same thing as this C value. The C value is 5 root 3. Because I know what C is, 5 root 3, we now know what the B value is. It's 30 minus 5 root 3. Let me write that down. B equals 30 minus 5 root 3. You cannot put the 30 and the 5 together. You cannot put the 30 and the 5 together because the 5 is a root 3. You can only add or subtract root 3s with other root 3s. We talked about that when we were dealing with adding and subtracting radicals. And a good way or a good reminder for me is if I tried to do that on this calculator, by the way, our calculator knows I can't put those together. This is simplest radical form. One of the reasons why I like this calculator, by the way. Now, if I want to know what A's distance is, I have to take that S value and multiply it by root 3. 5 root 3 multiplied by the root 3. 5 root 3 is the S. Now we're going to take that and multiply it by root 3. Look at what I have to do here. I have a pair of 3 and a 3. Now I should know what A is. Any questions? Last example. Number 22 says that this triangle has an area of 32 root 3 centimeters squared. The measure of angle A is 30. The measure of angle B is 90. What's the length of the sides? Express all answers in simplest radical form. So all they give us is that angle A is 30 degrees, angle B is 90 degrees, so that means C has to be 60. So I'm going to put that in the picture. It tells me that the area is 32 root 3. I'm going to write this down over here. Area equals 32 root 3. And I know that the area of a triangle is 1/2 base times height should equal to 32 root 3. Now, if I look over here, I don't have a distance. We don't have the base and the height. But what we do know is that in my formula, across from the 30 should always be S. Across from the 90 should always be, I'm sorry, that should be 2S. I'm sorry. Across from the 60 is S root 3. Almost messed up right there. But I got it. In this formula, the base and the height always have to be perpendicular to each other. So the ones that we're going to multiply are this one and this one. Let's write that down. Now this is where the math gets a little bit funky, but it should make sense to you. We know the base. The base could have been 7. I could have flip-flopped these because I can do multiplication in any order I want. But S times S root 3, I'm just going to reorder this. I'm going to do S times S. I have 2 factors of S. And then I have this root 3 that's multiplying. I'm just going to put it like that. I'm just reordering it. Multiplication can be done in any order. A times B times C is the same thing as C times B times A. And I have 2 factors of S, so S squared is how I kind of like put that together. I just moved the root 3 over. It's still multiplying. I am now going to multiply this whole thing by 2. 2 times this gets rid of that 1/2. Instead of halving it, half of 2 is 1. I get root 3 S squared. 2 times this other side is 64 root 3. I want the S squared by itself. I'm going to get rid of this root 3. It's multiplying. I'm going to do the opposite of multiplying by root 3. I'm going to divide by root 3 on both sides. Root 3 divided by root 3 goes into each other 1 time. 1 times S squared is S squared. Root 3 divided by root 3 goes into each other 1 time. 1 times 64 is 64. And then the problem looks really easy. Square root, square root. Technically, this should be a positive or a negative value, but because we're talking about a distance that has a positive area, we know that the side has to be a positive distance or a positive 8. Now, what is it, centimeters? So what are we dealing with there? Centimeters. Oh, and I probably shouldn't put a box around that because that's not what the question asked, Mr. Paramu. Always go back. It asks, what's BC? What's AB? What's AC? And once you know what S is, now you know what BC is. BC is 8 centimeters. AC is double that. AC is 2 times that amount, 16 centimeters. AB, on the other hand, in simplest radical form, would be 8 root 3 centimeters. That's the answer to the question. And we'll stop your notes right there.